I just checked now. Friday, you're having national.
There is maths class today.
Friday we have. You can check in your timetable.
Ma'am, is there exam on Sunday?
Shall we start? Boys, shall we start? Okay. Ready? Okay, so we had marked in our textbooks regarding center of curvature. We have seen pole. Correct? These are the two definitions we have already done. So you will notice that C is the center of curvature, and it is also the center of this sphere of which the mirror is a part. Is that okay? So that part of it we have already seen. And further, the center of curvature of a concave mirror lies in front of it. Abhishek, you will continue. You continue from there.
Please note that the center of curvature. The
Yeah.
center of curvature of a concave mirror lies in front of it. However, it lies behind the mirror in case of a convex.
So right now I'm just talking about a concave mirror. Can you notice that your center is lying in front of it? Okay, it's lying in front of it. Remember, because further we will also be talking about differences between convex and concave mirror. We can use one of these points as a point of difference. Okay, you remember to use it as a difference, right? Yeah. Continue.
The radius of the sphere which the reflecting surface of the spherical mirror forms a part is called the radius of curvature of the mirror.
Underline. Yeah.
It is represented by the letter R. You may note at a distance, BC is equal to the radius of curvature. Imagine a straight line passing through the pole and the center of curvature of the spherical mirror. This line is called the principal axis.
Underline principal axis. How do we define the principal axis? It is a straight line passing through the center of curvature and the pole. It's an imaginary line. Okay, you can extend it further here. You can extend it further. You can extend it further. Principal axis.
Remember that principal axis is normal to the mirror and its pole. Let us understand an important law related to mirrors who are active.
Okay. So I'm sure most of you have seen this activity. What are we talking about in activity? We are taking a concave mirror. Probably you have one in some science kit or something of that sort. And if you are having sunlight, you are focusing it on a piece of mirror until you get a sharp and a bright point. Probably you would have done with a lens. I don't know whether you tried it with the magnifying glass, which is the lens, you would have probably tried, but it is the same concept even for concave mirror. Okay. So what happens is when you are focusing your concave mirror onto the sunlight and it focuses the light at that point, it becomes so hot that you can use it as a solar heater also. You see that because you are focusing the rays of light onto a particular point. So any substance which is kept at that focus will become hot, and we are generating nothing but we are concentrated and we are generating the solar energy. Is that okay here? Did you recognize this diagram? Did you recognize the diagram that we had put up earlier? Converging mirror and diverging mirror. So did you see that? How it is actually moving away and it is coming closer, so that is converging and diverging. So you already got 2 points of differences. What are they? Convex and concaves. Converging mirror, diverging mirror, and second one, C. C is like in front of the mirror, whereas convex is like behind. Is that okay? Further, are you okay with this?
Yes.
Are you okay with this? That's not need for you to understand. It's just the wisdom. We are now going to see what are called as ray diagrams. Now, what is a ray diagram? Is we are going to talk about a couple of rays and draw from the object which is kept in front of the mirror, and we can predict where the image is going to be formed. Okay, so obviously we need to talk about certain rays which is coming from the object, for which we'd like to see that there are 3 of those rays which we are going to select. One is, I'll just draw a basic idea for you to understand. Now this is on your next picture, page number 138. Representation of images formed by spherical mirrors using ray diagrams. So we are using rays. Okay. Now, if you notice, there are 2 diagrams, a pair of diagrams which is constantly used. Have you all noticed that? One is for concave and the other one is for convex. Don't look at convex. Today I will do only the concave part of it so that you don't get confused. Okay, so it makes much more simpler. The very first diagram. What is this point called? P. This is your C, center. Exactly half of it will be what? Focus, which is going to be a F. We are not talking about focal length, we are talking only about focus. You see that there is a ray which is coming from some object here. So I am going to draw an incident ray. How do we know it is an incident ray? Obviously because of the arrow. Yes, coming from the object which is kept somewhere on this side. You understand? Always. The object is always going to be kept towards the left of the mirror. That's the rule. You have to remember that. Okay. Now, after reflection, what type of a mirror is this? Is it converging or diverging? Converging. It is converging. That means the rays are coming closer. So your reflected ray will pass through S. You see here. You see. Now, looking at the figure, can you tell me? Is it obeying the laws of reflection? This is reflection taking place. Correct? Is it obeying the laws of reflection? Look at the diagram there. What is the dotted line? From C to this point. What did we say? Angle I, and this is angle R. So it is definitely obeying the laws of reflection. Okay. So what is the first ray that we are talking? A ray which is parallel to the principal axis. After reflection, passes through F. Okay, we can take any of this. Jot down. Only this diagram, take it down. Small figures. Just draw small rough figures. Only for you to remember. This is your first of the figures that we are going to do. Let's look at the next one. Once again, your mirror. I'm putting P, C, and that's your F. Look at the second diagram in your textbook. Okay, point number 2. Do you see that? How is the incident ray passing in the second one? Look at this diagram. Look at this diagram here. Where is the incident ray? Passing through F. Okay. So we have a ray which is passing through F. I know that it is an incident ray because of the line. It is getting reflected. How is it getting reflected? See the diagram.
Parallel to the principal.
Yes. After reflection, it becomes parallel to the principal. Sorry. Parallel to the principal axis. Okay. So the line which I have drawn in red, this is your reflected ray. The one that I have drawn in black, this is your incident. Is it still obeying the laws of reflection? Yes. Because if you draw a dotted line from C here, that's your normal angle of incident and angle of reflection. Did you notice that this is nothing but flipped over?
Yes.
Easy to remember? This figure is nothing but a flipped over figure. Okay. Run, finish, right? Let's look at the third one. Once again, a concave mirror. Remember to draw the shaded portion. P, C, F. Okay. I'm taking my black pen and drawing a ray passing through C. What will happen? Draw a straight line passing through C. It's a straight line.
Again, come back, falling the same path.
Yes. After it hits the surface, it's getting reflected. Okay. It is getting reflected on the same path. So using my red pen, I'm drawing a line on this to show that it is getting reflected on the same path. Did you understand? Okay, let me go back again to the mirror. Look at this diagram, everyone. Put your pens down. Pens, pencils, put it down. Remember that this is your mirror. Okay, I'll call this as O and N. This is your incident. I'm talking about a plane mirror now. Okay? This is my incident ray. Correct? and we know that is the reflected ray. What happens if I reduce the angle of incidence? Angle is decreasing. All of you can see what I'm showing. It is decreasing here, decreasing, decreasing. So what happened to this? It will also decrease. Now let us say it is 5 degrees, 2 degrees. Now how much is it? 0. So what happened to a ray which is passing on the normal? It will come back again. Did you understand? A ray, incident ray on the normal will come back. That means it's getting reflected ray will also come back on the normal. Same thing is happening here. Incident ray passing through C is nothing but the normal. So reflected ray is also coming back to the same. Got it? Okay. Third figure. Yeah. So in all the three cases that we have done, it is obeying the laws of reflection. The fourth diagram that's given in your textbook is given, of course, but we hardly use it. Once again, this is your mirror, center, pole, and F. Did you notice how the incident ray is for the fourth one? Is it parallel to the principal axis? No. It is oblique and it is hitting the pole. So this is your angle of incidence. This is your angle of reflection. There is also another way that we can consider, but we usually don't consider that at all. So any of the two ways we can take it for construction of a data. Is it getting complicated?
No.
Easy? Anyone who has any difficulty right now? Yeah? Always we have to show our incident ray, and after it strikes the mirror, what is happening to the reflection? Reflected ray. So if you notice in this page, they're only talking about the rays that we can use. And I am talking only about the concave part now. I have not told you anything about the convex. Don't get confused. When I take up convex, I have to tell you about it.
Basically, we have to show the object and like where is the object.
That I cover. Okay. These I am just discussing only the rays. Object and other things. When are your schools starting? Already started? Your schools have started? Your schools have started?
Yes.
Has started. So which lesson in physics is this the lesson that they are
Haven't
starting?
started. All of them are at the same time.
Yeah. So when we are going to draw the ray diagrams for a concave mirror, there are 6 positions. How many? 6 of them. So the very first one, I will talk about what happens when the object is very far away. Once again, children, these are all geometric constructions. Unfortunately, today we do not have your geometry box. Okay? But I suggest that you repeat the same thing properly at home using your geometry set. Okay? Right. Now, usually in the schools, we suggest that you take this distance as, let us say, 2. Obviously, this is also going to be 2. Isn't it? Exactly half. And that's why I said you must use your school, the scale and instruments to draw a perfect curve even for the mirror. Right? Another thing that you should remember is whenever we draw the ray diagram, make sure that you're using a very sharp pencil, because in the board corrections, the papers go out. Any double line will not be considered. Understand what I'm saying? It should be a sharp pencil, just as you're doing your geometry constructions in math. It's the same thing. Right? The first one, look at me. Look at me. This is my object. What mirror is that?
Okay.
Where is the object? On which side of the mirror? Always on the left side of the mirror. It's very far. What's happening now? Where is the object? It's closer to C, but it is beyond C. Not beyond C. Beyond C. Now,
On C.
at C. Now, between C and F. Here and F. Here, how many positions? Count. Tell me. One where?
Infinity.
Very far away. At infinity. Object is at infinity. Beyond C. Between C and F.
Between F and D.
And the last one was got it? So that's exactly what we are doing. And we are considering different positions of the object, and we are trying to find out what type of images are. Exactly. First one. See the first one. This one. Where is the object? You have seen that it is at infinity. Incident ring, where have they drawn?
Parallel to the principal axis.
Above the principal axis, and it is parallel to it. What is happening to that ring after reflection? It is passing through F. Did you see that? So we are going to draw it. Our image is very, very far. Okay. So I'm showing dotted lines because it's so far. Did you notice there are dotted lines in the shape? Only when it is coming closer, I can show. Okay? I'm using a red pen to show. Right? There is another ray also. There are so many rays coming from our object. This is your object. Once again, I have to draw. These are all things that you need to use a scale to draw. Okay? This is another incident ray parallel to the principal axis. Maybe use my red pen here. So did you see that your reflected ray is intersecting? Where is it intersecting? At F. So this is where your image is going to be formed. You understand? Your image is going to be formed where these two rays are going to intersect. Correct? So let's see. Where is your object? Object is at infinity. Now you may take down the diagram. You don't need to cross a lot of shading cases. Not shading cases. Have you all got it? Blue line indicating incidental. Red line indicates reflected. Okay, so wherever the reflected rays are intersecting, that is where your image is going to be formed. Okay, so object I have written that it is already at infinity. Now let's write about the image. So we need to also understand where our image is going to be formed. Where is the position where it is intersecting at F? Its position is at F. Focus. What is the size? Look at the size of the object and look at the size of the image comparatively. Kitna bada hai? And you see here, it's just a small. So what will you say? Highly diminished. Okay, it is diminished. Means what? It is very, very small. Sizes. Okay. And it is real and equal. So the nature here will be real and important. I do hope in your school you will take the lab to do these experiments. No? No lab.
We already did.
Okay, let's try. Let me try to show it. Okay. Okay. Then I'm going on to the next one. So, boys. So whenever you're doing, boys, listen. So when you're doing this, because I want you to repeat at home again, use a proper scale. Take equidistance. If you're taking 2 here, it has to be 2. If you're taking 2.5, this has to be exactly 2.5. Did you follow? Okay, right? Yeah, and then you will get your ray diagrams correctly. Otherwise, it will go literally wrong. I'm just drawing an approximate figure of it, right? If you look at page number 138, you find this table here. You'll see this table. This table will basically tell you, right, regarding the position of the object. Look at the first one. Where is the position of the object? Infinity. It's very far away. Next, what is it telling us? Size, position, nature, art. This is what we have written. That's what exactly, what's the name? Yeah. If you are actually doing this experiment, that's what I was just getting out of it. It's possible for me to show, unfortunately, no. You can actually do this experiment. You can keep your mirror, concave mirror, and focus on something that's outside. Maybe I can look at a tree or an electric pole or something of that sort. Okay. If this happens to be your tree, you will find an image like this. You understand? That's why it is real and it is important.
Just in the perspective of that, the reflected ray, how is the representation of the image inverted?
And that's, I'll have to draw the entire set of figures for you. Okay? Because the ray of light which is passing here, after reflection is coming back here. Do you understand? The ray which is here, right at the tip, is getting reflected and that is how it is coming here. Imagine there's another ray which is coming from here. Okay, so at each point it is getting inverted. You're getting an inverted image. Is that okay? Okay. So this was the first of the images. We said our object is very, very far away. Next position will be what? Beyond C. Just beyond C. So that is what we are going to do. Second position, object is what line is this?
Yes.
Principal axis. What mirror? Yes. So you can write it as M dash, which is your concave mirror. What is P? No, P. C.
Center
of the
Center of curvature. F.
focus.
Yes. So this is going to be your starting diagram for any of this ray diagrams. Now let's say I have drawn that is my object. Okay. And an object I'll show by writing A, B. Why am I putting an arrowhead? Just to understand this is your inverted. This is your object. Okay, let's see what is going to happen here. From the tip of the object, I have a straight line which is indicating your incident ray parallel to the principal axis. I'm sorry, it's not very parallel. Draw a better figure. Okay, it's better. What happens to this ray? Will it stay there? What happens? It's getting reflected. Passing through what? Passing through focus. So using my red pen, a line passing through focus. It has to pass through focus.
Between C and F, right?
We see. I don't know. I'm going to draw and see. You can actually see for yourself. There's no need for you to learn up anything. The moment you draw, you go. is the second ray that we can take?
Yeah.
A ray which is passing through, look at your textbook,
See.
passing through C. Did you notice that? If a ray is passing through C, what will happen?
will again come.
Yes, it will get reflected back. So what am I going to do? Starting from A, passing through C. Okay, it's hitting back again. Right? Where is it intersecting?
Between C and F.
So that is going to be your reflection. Just going to be formed. So your image is going to be formed wherever these two rays are meeting at this point, and it is going to be an inverted image. How will I show it as an inverted image? I'll write it as A dash B dash. You understood why it is A dash B dash?
Because the image is
See here. See here. This is my object. I'm writing it as A B. This is my image. I'll write it as A dash B dash, or you can say I. Sometimes you also write it as that is showing the image. Here. Now let's jot down position, size, and nature. Where is the position between C and F? Everybody look here. Right? Position is between C and F. Size, is it bigger or smaller? It's smaller. Isn't it? It's smaller than that of the object. Nature,
real
it is real. Whenever it is real, it has to be invented. Right down. Position will be smaller than the object, right? But you can also write down as diminished. This is highly diminished, that is diminished. And what is the nature here?
Real.
You understand? If you use your geometry box, your scale, you will not have any problem. You can immediately make out that the image is formed properly. Okay. Look at the board. Cos diagram, very far away. Now we have come beyond C was our second one. Third position. And so my object is at C now. What's your name? What is this like? I'm asking him, no one else will answer. What is this like? I've already finished the three. All of you who know, put up your hand. Principle what? Access. Don't prompt it. Don't prompt it. We're all trying to learn. If he does not know, we will all answer. Yes. This is your principal axis. Principal axis meets this mirror at a point called what is this? What is P? Class? 4. Very good. Okay? Tell me. What is C? What does it tell you about the center of curvature? Why do we call it a center of curvature? Think of how the mirror is made. Yes. Okay, what is it? Okay, it is the center of the sphere of which the mirror is a part. That's what it is. Okay. Okay. Um, where do I draw F? Anywhere between C and P. Put a line. What is the measurement? Exactly. Okay, where is your P going to come? Whatever this distance, if it is 6, it's going to be exactly half. If it is 5, it's going to be exactly half. So what do you say? Yes. Radius, half of it will be your focus. Okay. So where have we kept our object? At C. So at C, I'm going to draw my object. Alright, tell me which ray am I going to take? What is the first ray that I'm going to take here? Starting from where? Starting from where? From the tip of the object. How will that ray run? It is go parallel to the principal axis. What will happen to this ray now? Magmay. Will it stay there? It's happy, I don't want to move. Then what will happen? It will reflect. Through where? It will go through where? To the F. Yes, very well. Through F. So this is where I have, okay. That is where it's going to be. Second ray, the one that I am going to select, will be a ray passing through F. I gave you those 3 diagrams at the starting. I gave you these 3 diagrams. If a ray is passing through, yes, correct. A ray passing through F, after deflection will become parallel to the principal axis. Look at the board, everyone. Look at the board, understand what we are doing. A ray passing through F. Okay. What will happen? This is your incident ray. After reflection, becomes parallel to the principal axis. This is how it. Okay. Unfortunately, I think this is where it's. Okay, it should be somewhere like that. Absolutely not. I don't have a scale. Okay, so this is the best that I can do. Okay. Fine. When you notice your image to be, where is the image? At C. Okay. Object is also at C. Image is also at C. Okay. So I just put it down for you. This is how it looks. That's your object. Your image will be like this. AB is your object, A dash, B dash is your image. What else did you notice about the image? Size, same size. Okay, 3 centimeter, this will also be 3 centimeter. Is it inverted?
Yes.
Yes, it is inverted. If this is your object, this is your image. It is inverted. If it is like this is your inverted. Now I've just drawn this part. I've drawn this part so that it is clear. Okay. Make sure that this diagram is done. You will have to use your scale and your calculation. Yeah. Okay.
And the position will be at
Yes. Position. Position, what will you write? Axis. Size? Same size. Same size. See? Same size as that of the object. Last will be nature. Yes. It's real and safe. If you check it out in your table, we have already finished 3 diagrams. Okay? And you can see the corresponding. Till now, did you notice something? What is the nature here? All 3 so far have been real and good. Now I'll rub out the first one. Okay. Let's look at the board. What is your next position? We are already at C. Yes. That means the object is coming closer and closer to the mirror. What did you notice about the size of the image form? पहला वाला क्या था? First one was very small. Now it is bigger. Now it is becoming bigger. Yes. So as the object is coming closer and closer, the image is becoming bigger and bigger. Got it? Okay. If the object is coming closer to the mirror, the size of the image is bigger. Position number 4. Okay. Let's see whether we can do it. I'll ask one of you to come and do it on the board. First, you do it in your book currently. What is the first way that we are going to talk about here? From where will we start? From the tip. Okay, from the tip. How will it go? Parallel to the pencil. And then after reflection?
it will go past the word.
Yes. Past. So the other one, of course, we can take either passing through F and becoming parallel, or we can take one passing through C. That way is also valid. The other one is we can talk like this. See, a ray which is passing from the tip, passing through C, like that.
What if I pass it through X?
Also is possible. There are two ways of doing
So
it.
the
Same thing, same thing. We'll also make a similar to that. I'll draw that one also. Yes. Image will come beyond. So the first one, parallel passing through C. Second one, a ray which is passing through C will hit the surface, come back on the same. So here we have got both arrows.
What will be the nature?
A dash, B dash.
Equal diagonal inverted and shape. Equal and inverted.
Okay, hold on. Okay, let's see here. Class, position,
Means beyond.
yeah. There is your image. We are talking about image. Where has the image gone?
beyond
Beyond C. Size has been completed.
enlarge.
Yes, it's bigger. Enlarged, it's bigger, right? Because the object is coming closer and closer. Nature, anything that's important, obviously. Any two ways you can say. The other way of doing it, I will show it to you here. There's another way of doing the same thing. Instead of taking this ray which is passing through C, I just change it here. Notice what is happening. Okay, the same thing can be done another way. So instead of taking this ray, right, we just hold on to this. The other ray we can say is passing through F and becoming parallel to the principal axis. So we use the same image. That way is also correct. Did you get it? Second ray passing through F. After reflection becomes parallel to the principal axis. We get the same image. I'm going on to the fifth one. Where have we come now? The object where the F. Yes. Now if it is coming closer, it is going to be at F. This is your position number 5. First ray parallel to the principal axis and passing through F. Second ray passing through C Obviously, it will retrace. Yeah, it will retrace its path. So another ray which is passing through C and passing like that. These rays are almost parallel, so we assume that they don't meet, or we assume that they are making at infinity. So somewhere so far, okay, the image form will be very, very far and will be very enlarged. Highly enlarged. Position is, you can say, at yeah, what's the doubt? So how many we have finished? Five. What is the nature for all the five of them? Sixth one is different. I'll not do the sixth one. It will be a red pen version. We'll keep the sixth one for the next class. Homework? What's the homework? All diagrams to be drawn once again using your scale and accurate measurements. Yes, in the same book. These are rough images that you have drawn today. Okay. Use a proper protractor, or even if you're having a closed circle, you can use that. Yeah, you've done it, but please repeat it. Yeah. Thank you, class. Friday maths class. Friday maths class. Coming Friday.
निशान आता है
नहीं छोड़ दिया